Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Higher Level Paper 2 Time Zone 1, May last year 2023. If you find this video is helpful, don't forget to subscribe and let's get started. Question number 1. This question is about acid-base properties. Deduce the ionic equation, including state symbols for the reaction of hydrogen chloride gas with water. That would be HCl in aqueous state, react with water in liquid state, producing Cl- in aqueous state, and H3O plus ion in aqueous state. HCl here donates proton to water and is acting as an acid, while H2O accepts proton from HCl and is acting as a base. Calculate the pH of 0.5 molar hydrochloric acid. So pH will be negative log concentration. So it's 0.3. Explain why a solution of ethanoic acid has a higher pH than hydrochloric acid of the same concentration. Ethanoic acid is a weak acid that dissociates partially, while HCl is a strong acid that fully dissociates. Therefore, pH of ethanoic acid is higher than pH of hydrochloric acid. A pH probe can be used to distinguish between the acid in part A3, between weak acid and strong acid. Identify another simple instrumental method that could be used in a school laboratory to distinguish between the two acids. You can use conductivity. The conductivity of solution of a strong acid is higher than weak acid, as it is fully dissociates, producing high concentration of ions even though it has the same concentration. So because a strong acid is fully dissociated, so the ions that will be produced will be higher, or the amount will be more compared to the one that partially dissociates. So conductivity of a strong acid will be definitely higher than a weak acid. Outline how the instrumental method identify in a part A4 conductivity distinguish between the acid and the part A3. The instrument will have higher conductivity on HCl due to higher amount of ion, as I said, because HCl fully dissociates. So even though they are on the same concentrations, but the amount of ions of HCl is higher than ethanoic acid that is partially dissociate. So the instrument will have higher conductivity on HCl because higher amount of ions. Outline one chemical test other than indicator that can distinguish between the two acids in part A3, weak and strong acid. You can add carbonate or metal like Mg, for example. So if you add carbonate or Mg, there will be more bubbles per unit time because it will react with HCl more vigorously or stronger compared to the one with the weak acid. So this will be per unit time, or obviously the reaction will be faster reaction for HCl per unit time for HCl, or the metal disappear faster in HCl. So Mg will react with HCl and it will be finished, but disappear faster in HCl compared to ethanoic acid. A neutralization curve for a weak acid, HA, and a strong base is given. So estimate the pKa of HA. So for the pKa, that would be half of the equivalence point. So you can get the half of the equivalent points here around, if you get, so that this will be the equivalent point. So half will be around here. So 1, 2, 3, 4, 5, 6, 7. So half. So it would be around here. If you zoom it, okay, it's not really 5. So it's below 5. So we can say 4.8 or 4.9. So let's say between 4.7, I would say 4.9, definitely below 5. So pKa is the pH of half equivalent point. Explain using an equation why adding a strong base to the weak acid HA leads to very little change in pH in the buffer zone of the graph. So the reaction would be HA produce H plus and H minus. So if you add OH minus, it will react with H plus or neutralize by H plus. Okay, let me explain. HA will produce H plus and H minus. So HA is a weak acid. So H plus is a conjugate base. So when you add H plus, it will cause the equilibrium shift to the left, creating a large amount of a weak acid. Adding H plus, it will react with OH minus, so equilibrium shift to the reducing the increase in H plus. If you add OH minus, it will react with H plus as well. So equilibrium shift to right, reversing the decrease in H plus. And if you add water, both sides affected equally, so pH unchanged. Buffer solution, both HA and H minus must large so that any changes in their concentration when you add an acid or base are small. In a separate experiment, 80 centimeter cube of 0.1 molar ammonia was added to 40 centimeter cube of 0.1 molar HCl. Determine the final pH of the solution. Use section 21 of the data booklet. So NH3 will react with HCl, producing NH4 plus and Cl minus. So volume of NH3 is 80 centimeter cube. Let me just write it here so it will not disturb the equation. So that would be 0.08 decimeter cube, and the concentration is 0.1 molar. So for NH3, the mole will be 0.08 times 0.1. You will get 0.008 mole. And for HCl, it's 40 centimeter cube. That would be 0.04 decimeter cube times 0.1 hydrochloric acid, the concentration. That would be 0.004 mole. Okay, so HCl will be acting as a limiting reactant, so this will be finished, and we have 0.004 excess for ammonia. So to find the concentration, we need the concentration of ammonia, final concentration of ammonia, and final concentration of NH4 plus, also 0.04, because it will produce 0.04 as the limiting reactant mole is 0.004. So the final concentration for, I would say, concentration of NH3, so I would put final here. That would be N divided by V, so 0.004 divided by 0.12. So 0.12 comes from the addition of volume from ammonia and HCl. So 80 plus 40, that would be 120 centimeter cube. So it would be 0.12 decimeter cube. Okay, so divided by 0.12, you will get 0.033 mole decimeter cube. That would be the same also for an H4 plus. It will be 0.004 divided by 0.12 will produce 0.033 mole decimeter cube. Okay, so from section 21 data booklet, you can get pKa is 14. Okay, pKa plus pKb, the formula is 14. So pKa will be 14 minus pKb of NH3. So we can check the data booklet for section 21 is NH3. So pKb is 4.75. So 14 minus 4.75, you will get 9.25. This is not done yet. So pH would be pKa plus log concentration of NH4 plus divided by concentration of NH3. So pKa is 9.25 and log the concentration is the same, 0.033 and 0.033. So it's finished. You will get 9.25. Question number 2. The periodic table is a useful tool in explaining trends of chemical behavior. Annotate and label the ground state orbital diagram of boron. For boron, the atomic number is 5, so the electron will be 5 as well. So you will have 1s2, 2s2, and 2p2. And the short notation use He. He has 2 electrons, so this will represent He. So you've got 2s2, 2p2 left. So 2s2 and then 2p2 left. So the one will be 2p. Okay, so based on the rules that one orbital only 2 spins, and then when you first write the orbital should be pointing it up, and then continue and you can pair up by pointing it down. Sketch the shapes of the occupied orbitals identified in part A1. So we have S and P. So S will be like this, circle. And P, because of the first, this P, X, P, Y, and P, Z. So you can put in X, but actually, based on the mark scheme, you can put in any. It's acceptable. Explain the decrease in first ionization energy from Li to Cs in group 1. So it's going down a group. As you go down a group, number of electron increases, causing more electron shells, making valence electron, the electron on the outermost shell, further from nucleus. Thus, the radius gets larger, less attractive forces, so easier to remove electron. State the electron domain geometry of the ammonia molecule. So ammonia, it's like this. Okay, geometry will be 4 because it has lone pair here. Be careful with the geometry. So geometry is tetrahedral because it has 4 geometry here. It's not the same with the molecular shape, so be careful. Deduce the Lewis electron dot structure of ammonia and sketch its 3D molecular shape. So for the Lewis structure, that would be usual right here. 1 electron from H, 1 electron from N, and you will have 1 lone pair. And for the 3D molecular shape, okay, this is a line in the plane of paper, and this is the dark wedge projects towards the observer or you, and this one is dash wedge projects away from the observer or you. Explain with reference to the forces between molecules why ammonia has a higher boiling point than phosphine pH3. If we write down the Lewis structure NH3 and has 1 lone pair, pH3P comes from group 5, so it has 5 valence electron. That would be the same with NH3. So there are no difference. They have dipole-dipole attraction because it has lone pair. They both are polar molecule, but there is difference between these two. It has hydrogen bond between N and H. So both have a lone pair, thus have dipole-dipole attraction. However, ammonia has hydrogen bonding, makes it has higher boiling point. Ammonia is manufactured by the Haber process, N2 plus 3H2 produce 2NH3, and it's exothermic. Okay, So outline what is meant by dynamic equilibrium. The rate of the forward reaction is equal to the rate of the reverse reaction in a closed system. Deduce the Kc expression for the reaction in the part D1. So Kc is the concentration of reactant to the power of their coefficient, product, not reactant, and concentration of N2 divided by concentration of the reactants, and H2 to the power 3 because coefficient is 3. Determine the entropy change for the forward reaction to force significant figure using the data given. So delta S would be delta S product minus reactant. So the product is NH3 and reactant is H2 and N2. And NH3 coefficient, don't forget, is 2, and for H2 is 3. So that would be 2 times 192.8 minus reactants N2 191.6 plus H2, the coefficient is 3 times 3 times 130.7, you will get negative 198.1 joule, mole. So 4 significant figures. Calculate the temperature in K below, which this reaction becomes spontaneous. So the reaction is at equilibrium, so delta G will be 0. Delta H is negative 92 kilojoule per mole. So delta H is negative 92 kilojoule per mole, and delta S we get negative 198.1 joule per k mole. So we need to convert this into kilojoule per mole because delta G is in kilojoule. So that would be negative 0.1981 kilojoule per k mole. As delta G 0 because it's at equilibrium reaction, the formula is delta H T delta S. So here will be negative 92 minus T minus negative 0.1981. So you will get T 464 Kelvin. The value of Kc for this reaction is 6.84 times 10 to the power negative 5 at 500 degrees Celsius. Suggest with a reason how lowering the temperature affects the value of Kc. So lowering temperature, but the reaction is exothermic, as you know. So when we lower the temperature, the position will shift into the exothermic reaction. So let me write down here. So N2 plus 3H2 produce 2 NH3. This site will be exothermic because delta H is negative 92, and this site will be endothermic. The reaction is exothermic. So if the temperature as the temperature decreases, the position is shifted in exothermic reaction, and Kc increases as it moves towards product. Okay, so it moves towards product. Therefore, Kc will increase. Calculate the standard Gibbs free energy change in kilojoule per mole for this reaction. So the temperature is 500. So temperature is 500 degrees Celsius. That would be 773 Kelvin. And Kc is 6.84 times 10 to the power negative 5 here. So to calculate delta G, that would be RT and Kc. So 8.31 times 773 times 6.84 times 10 to the power negative 5, you will get 60,600 J per K mole. Let me just write, like, you can just remove the point, so it will be 61.6 kilojoule per mole. Okay, the Haber process requires a catalyst. State how a catalyst function. Catalysts will alternate pathway and lowers activation energy. Sketch a Maxwell-Boltzmann distribution curve showing the activation energies with and without catalyst. So the curve will be like this. Okay, so this part, so we have two parts right here, the one that with and without catalyst. So this part will be EA without catalyst, and then this one EA with catalyst. Okay, because the kinetic energy with catalyst, it's lower, I mean it's right here, so it's the kinetic energy is faster and higher compared to the without catalyst. So in this part, as you can see, the reaction is moving faster here as well. So the one that further is without catalyst, and then the one that in this part is with catalyst. Suggest how the progress of the reaction could be monitored. You can see the change in volume, or maybe the change in pressure, or maybe the change in temperature. So you can choose any, as is only one point. Outline the meaning of homologous series. Homologous series, compounds that have the same general general formula or the same functional group. State the preferred IUPAC name for the following compound. So let me try to make this structure become clear. So this will be CH, this will be CH3, and this will be CH2, and this will be CH. You get CH here, and this will be definitely CH3. It's quite difficult for me to write if it's too big or zooms too much. Okay, so here there is alkyl chloro, so Cl attached to C number 2. It should be lowest number, so cannot start from this because it will be number 3. So it has 2 chloro and 4 C, so it's butane. So that would be 2. So that would be 2 chlorobutane, and in this you have CH2 and this one CH and this CH3 and then CH3, but the difference here, it's on number 1 and number 2 and number 3, only 3, so it's propane, but Cl attached to the C number 1, so it's 1 chloro. And we have alkyl here at number C number 2, so it's 2 methyl. So we start with 1 chloro because chloro and methyl, so C comes first, so it will be 1 chloro, 2 methyl propane. If you write 2 methyl 1 chloropropane, that would be incorrect because C and methyl, chloro and methyl, C comes first. Okay, identify one chiral carbon atom present in one of the following structures with an asterisk. Chiral has attached the carbon atom that attached to the 4 different atoms. So if we try to write the Lewis structure for this, it will be CH3, CH2, and Cl. This C will attach with A, and we have CH3, and the other one would be CH3, CH2, CH3, and you've got C that will be attached with H, and here H as well, and here Cl. Okay, so definitely this one because it attached to CH3, H, Cl, and CH2. Definitely 4 different groups, but for this one it's H and then H, so it's not chiral. So the answer will be this one. This C is chiral atom. Butene can be polymerized. Draw a section of the resulting polymer showing 2 repeating units. So for butene, CH2, CH, double bond C, and HCH3. Okay, so to repeat the unit, we need something right here. This will be your brackets, so C and H, CH2, so CH2 CH, and then I continue with C and H again and CH2. Okay, so this will be 1 unit. So we just repeat one more time. Okay, because it becomes single bond now, so this will be all CH3. And don't forget the bracket and N. Chloroethane can be converted into ethanoic acid in a two-step process. So identify reagents for each step. So as you can see, chloroethane and ethanol. Chloroethane will be CH3, CH2, Cl, and ethanol CH3, CH2OH. There are no difference in C number, only the functional group Cl replaced by OH. So it's a substitute reaction. So because it's OH here, so we need a reagent that contains OH. That would be maybe KOH, or you can also choose NaOH. Okay, so for ethanol, ethanol is a primary alcohol, and when it is oxidized, produce ethanoic acid. So for oxidation, the reagent could be KMnO4 or acidify potassium dichromate. Identify the type of reaction that takes place in step 1, part B. Step 1, part B is nucleophilic and also substitution. Nucleophilic, so DOH negative ion as a nucleophile is attracted to the partially positive carbon atom. And for the substitution, one atom or group, which is Cl, is replaced by another group, which is OH. So the answer will be nucleophilic and substitution. Okay, sketch the mechanisms of the reaction for step 1 in part B using curly arrows to show the movement of electron pairs. So it's a substitution reaction. OH substitutes Cl minus. So it's a chloroethane. Okay, so chloroethane, so CCl and then CH3, H and H. So if we have OH minus, so OH has, let me just put it down, put it up here so it's clear. So O will move here, and this is partially, Cl is partially negative, so C will be partially positive. Therefore, it will be, let me just draw this first and I will explain you why it's like this. And the product will be and Cl minus. As I said before, the nucleophilic OH minus ion is attracted to the partially positive carbon atom and substitute Cl here. So the reaction mechanisms occurs by breaking the carbon halogen, carbon chloride bond due to nucleophilic attack and departing of the leaving group simultaneously. So the leaving group is Cl. The hydroxide ion, as a nucleophile, is attracted to carbon and forms the transition state. The chemical structure illustrated here in square bracket is not considered as an intermediate product. It is just a halfway step due to atoms being broken and made continuously. It continues with the departure of chlorine as a leaving group and produce alcohol. Identify the products formed from the reaction of ethanol and ethanoic acid in the presence of an acid catalyst. So when it's alcohol react with carboxylic acid, it will produce ester and water using concentrated H2SO4 and heat. So when ethanol react with ethanoic acid, it will form ester. Ester is alkyl alkanoate, so it will be ethyl ethanoate and water. Okay, so next question. Redox reaction can be used to produce electricity. State the oxidation state of sulfur copper 2 sulfate. So copper 2, it will be 2 plus and sulfate SO4 2 minus. So it will be CuSO4. S is cancel out. So O is -2, so that would be -4, and we know Cu is +2, so to become 0, to be equal to 0, so S will be +6. A voltaic cell was constructed using a copper 2 sulfate and copper half cell and zinc sulfate, zinc half cell. Outline Y electron flow from zinc copper when these half cells are connected with a wire. If we see the data booklet, so that would be section 25. Okay, zinc is more reactive compared to copper. Okay, copper right here and zinc is right here. So because zinc is more reactive, therefore I'll just write it here. So zinc is more reactive, thus it is easily to lose electron. If it's more reactive, so it tends to get oxidized, and oxidation is losing electron. Formulate equations for the reaction taking place at each electrode. It's Zn is experience oxidation. Okay, and as this formula, so NOx, and I will write here NOx and cath red. So oxidation will take place in the anode. So oxidation losing the electron. So Zn2 plus, sorry, so losing the electron will be the other 2 plus the other side, and cathode, which is Cu, will experience reduction, which is at the cathode. So reduction, gaining electron, so Cu2 plus will be on the left side, so you produce Cu. Okay, this solid, this aqueous, solid, and aqueous. Calculate the standard cell potential for the voltaic cell in part B. We use section 24. Okay, So E cell will be reduction minus oxidation. Okay, for oxidation, N-ox, so Zn will be oxidation. So we start with Cu2 plus 2 electron. That would be plus 0.34. And for oxidation, Zn, that would be this one, negative 0.76. So it will be plus 0.34 minus 0.76, and you will get plus 1.10 volt. Calculate the standard Gibbs free energy change for this reaction. Delta G will be NFE. So N is number of electron. There are 2 electrons involved in the reaction, so that would be 2. And F, if you see data booklet, the number will be 9.65 times 10 to the power 4, and the E cell is 1.10. So you will get negative 212.3 kilojoule per mole. Double salts are substances with 2 cations and 1 anion. A hydrated sulfate containing 2 cations has this percentage composition. So the total should be 100%. So to find, the first one, the question is draw one lowest electron dot structure of the sulfate ions. Okay, so it will be calculate the percentage of oxygen present in double salt. So the total should be 100. So we just need to find the number of oxygen by eliminating all of the number available in the table. So you will get 56.67%. Determine the empirical formula of the double salt. Use section 6 of the data booklet. You definitely need to find out all the moles number of each element or each element of the table, and then you will find the empirical formula. So first we start with N, 7.09. You can refer back to the table. So divided by its relative atomic number, that would be 0.506, and then we continue with H. That would be this, and then S, 16.22 divided by 32 will be 0.506, and then CO, 58.93, and then oxygen, you get 3.54. Okay, you definitely cannot find the empirical formula by this way. So we will divide all of this with the smallest number, which is this one. So divide all by 0.253. So 0.506 divided by 0.253, this one as well. So you will get N2 H20 S2 CO1 and oxygen 14. So the empirical formula is N2 H20 S2 CO and O14. Okay, so next, the molar mass of the empirical formula is the same as the molar mass of the formula unit. Deduce the formula unit of dehydrated double salt. Okay, so the empirical formula is N2 H20. Let me just write it down below here. So it's N2 H20 S2 CO O14. So it said the molar mass of the empirical formula is the same as the molar mass of the formula unit. So you just need to rearrange this and find out the formula unit of the hydrated double salt. So hydrated, definitely it contains H2O and H2O, and then double salt. Okay, so the double salt means it contains two different type of ions. So from N2, H2, S2, CO, and O14, we've got N, H, S, CO, and O, and water, which is NH2O. We don't know yet. So how do we find the double salt? Double salt means contains two types of ions. So if we see N and H, we can think ion is NH4 plus. And when we see S and O, we can think of SO4 2 minus. And we have metal, which is CO, and we can think of NH2O. Okay, if we calculate CO and then S right here, so we need to have the same number with this formula right here. And as you can see, N is 2, so we need to multiply by 2, and S also 2, so we need to multiply by 2, and then left for H2O. So CO is 1, N is 2, H is 8, and then S is 2, O is 8. So left 12H and 6O. So we can definitely say N is 6. So when we write the formula, we cannot write the charge. So therefore, we can do CO NH4 2 SO4 2 6H2O. Alright. 1.2 of the double salt was dissolved in water, and an excess of aqueous barium chloride was added, precipitating all the sulfate ion as barium sulfate. Formulate an ionic equation, including state symbol for the reaction of barium ions with sulfate ions. So barium ions is group 2, so plus 2 is an aqueous with sulfate ion, SO4 2 minus aqueous also will produce BaSO4 but solid. Calculate the mass of barium sulfate precipitate. Use your answer to part A3 and section 6 of the data booklet. Okay, so to find the mass of barium sulfate, so it's sulfate, so we need to calculate for the sulfate from the salt, which is mass of the double salt divided by molar mass of the double salt. It's 1.2, and the molar mass of the double salt also you need to calculate. That would be 1.2 gram divided by 395.229 gram per mole. So you will get 3.04 times 10 to the power negative 3 mole, but you don't forget to times 2, because in double salt we have 2SO4, right? 2SO4 here. So times 2, you will get 6.08 times 10 to the power negative 3 mole. So to find M of BaSO4, as we know, mole of SO4 is equal to the mole BaSO4. So to find M, N times Mr, so 6.08 times 10 to the power negative 3 times 233 gram per mole, you will get 1.42 gram. All right. So for the next question, the element sulfur has many industrial uses. Determine the standard enthalpy of reaction. So standard enthalpy will be product, okay, minus reactant. So product is SO3, reactant is SO2. So that would be negative 395.8 minus 296.8, negative 99 kilojoule per mole. Formulate equation showing how SO2 and SO3 lead to acid deposition. So SO2 as an aqueous react with H2O, produce H2. Okay, so it will be equilibrium here because H2SO3 is the weak acid, and SO3 react with water. It's not an equilibrium because H2SO4 is a strong acid. Explain the polarity of the SO bond. Use section 8 of the data booklet. S and O. Section 8. Okay, so section 8 is about the electronegativity. So S and O. S is 2.6, O is 3.4. So O is more electronegative compared to S. Therefore, O is partially negative, S is partially positive. Oxygen is partially negative, and sulfur is partially positive. The combustion of 0.1 moles of sulfur was demonstrated in a school laboratory using the following apparatus in the fume cupboard. These are the data. Is 0.1 moles. Calculate the enthalpy of combustion of sulfur. So to calculate the enthalpy, that would be Q mc delta T divided by mole. So 50 gram times 4.18 as a C, specific heat capacity, and then 35 minus 20 delta T divided by mole 0.1. That would be negative 31,350 joule per mole, or negative 31.4 kilojoule per mole. Okay, so it will be negative because the temperature rise, so increase in temperature, so it will be negative. Okay, so suggest the major source of the systematic error in the experiment and an improvement to reduce this error, because usually for the enthalpy the error is very common that the heat will lose to the surrounding. And how to improve this? You can put a lid on a beaker, or you can also, this is only one of them, or you can use insulator for the apparatus, or you can also use a bomb calorimeter, is a specific apparatus to calculate the enthalpy change. Calculate the percentage uncertainty in the temperature change to two significant figures. As we know, the initial temperature is 0.5 degrees Celsius, and then the final temperature is 0.5 degrees Celsius. So to calculate percentage uncertainty, because it's adding, okay, so you need to add this both 0.5 plus 0.5. You need to add these two uncertainties and divided by measured value, which is the difference between final and initial temperature, which is 15, and times 100. So it will be 6.7%. So it's only two significant figures. Suggests one way of reducing the percentage uncertainty in this experiment. Uncertainties is caused by instrumentation error. So it's about the instrument. Maybe you can use more precise balance, or maybe more precise thermometer. Calculate the overall percentage error of this experiment. So to calculate the percentage error, that would be absolute experimental value minus accepted value divided by also accepted value. Okay, so we use the section 13 of the data booklet to get the experimental value, accepted value. So 13 so it's what was the, so is sulfur, okay, so sulfur negative 297. Okay, so for the experimental value should be 297. It's negative, but is absolute, so it's okay to not put the negative sign. Minus 31.4. That's why I do the kilojoule per mole, because from the data booklet is kilojoule per mole. Okay, so you need to be careful. The unit should be the same. Divided by 29.7 times 100, you will get 89.4%. The structural formula of two esters of formula C3H6O2 are shown. Deduce the number of phenol you will expect to find in the H NMR spectrum of each compound. For NMR is based on the environments of proton, which is H in molecule. We can see here it has 1 CH3, 2 CH2, and 1 H. So it will have 3 phenols. And for this one is 1 CH3, and then we have CH3 here as well that attached to different type of carbon. So this will be 2. Outline why infrared spectroscopy is not used to differentiate between the two ester. So 2 ester, it has C double bond O, okay, and also CO here. So 2 esters also, they have the same functional group. So if it has the same functional group, infrared spectroscopy that is used to identify the functional group will not work because it will detect carbonyl group for both esters. So the reason is same type of bonds. So if like that, it will have the same wavelength, okay, absorb, because the type of bonds are the same. You can choose one of them. A series of experiments were carried out at different temperatures, and the rate of reaction in mole per decimeter cube second was determined for each. The rate constant for the reaction of propanone with iodine was calculated, and the process data is represented in the following graph. So to find gradient, the formula will be negative EA divided by R. We need to find the gradient first. So gradient will be negative EA, activation energy. That will be rise over run from the graph. Okay, so I will choose this one and this one. Okay, that would be negative 1.0 minus negative 3.0. Okay, so it's here and it's here. So 0.0032 minus 0.0035 will produce 6,700. Right, so for negative EA will be negative 6,700 times R. You get 56 J per K mole. Explain why a colorimeter set a wavelength of 500 nanometer is not suitable to investigate reaction of Zn2 plus compounds. Okay, first and very obvious reason, Zn is not a transition metal, as it does not form a color compound, as it has complete or full D subshell. So for, I'll just write up here. So the atomic number is 30. If we do the electronic configuration, 4s2 3d10. Okay, so it's full. Therefore, or thus, no absorbance will be syn. Nitrogen 2 oxide radicals NO catalyze decomposition of ozone. Formulate equation showing how NO radical acts as a catalyst in this reaction. So ozone will decompose, become oxygen and O radical. Then NO radical gas will react with ozone and producing NO2 radical gas and ozone. NO radical also, when it react with ozone, produce NO radical and oxygen. So that's how NO radical acts as a catalyst in the reaction. Chlorine also forms free radicals. The bond enthalpy is 4.02 times 10 to the power negative 19. Calculate the minimum frequency. So E H times V. H is Planck's constant. If you find in the data booklet, that would be 6.63 times 10 to the power 34. And V is frequency, can be in the S to the power negative 1 for the unit. So V will be E divided by H is 4.02 times 10 to the power negative 19 joule divided by H 6.63 times 10 to the power negative 34 joule second. So you will get 6.06 times 10 to the power 14 per second or hertz. Okay, so calculate the formal charge. Calculate the formal charge on each atom in the 2 Lewis structure of the NO radical. Okay, so for formal charge, that will be number of valence electron minus half times number of bonding electron minus number of non-bonding electron. Okay, so for oxygen, first oxygen valence electron is 6 times half 1 2 3 4 bonding electron times 4 minus it has 4 electrons non-bonding electron, so you get 0. For nitrogen, that would be 5 valence electron because it's the group 5, and then bonding 3 bonds, so it will be 6 electron minus it has 1 non-bonding electron here, it will be positive 1. And for oxygen, if I do the calculation here, it will produce 0. It's not the same like a mark scheme for the IB mark scheme. I double check this, we can do it together again here. For oxygen number 2, the valence electron is 6 minus half, so it has only 1 bond right here, so times 2 minus there are 6 non-bonding electron here, so it will produce 0. Okay, but for the IB mark scheme, it writes IB mark scheme shows as negative 1 here. Okay, so for the structure B, FC will be 6 first O minus, so 2 bonds, so it will be half times 4 minus there are 4 non-bonding electron, so it will be 0. And for the second for N, it will be 5 minus half, it has 3 bonds, so times 6 minus 2, because it has 2 non-bonding electron, you get 0. But for third one again, okay, So this O 6 minus, it has only one bond, so half times 2, so 2 bonding electron, and minus, there are 5 non-bonding electron, so we will get 1. Okay, but IB give this as 0. Therefore, this will affect the answer here. So Lewis structure A is more stable, suggests giving one reason whether the formal charge model support this. For the IB will choose B structure is more stable because IB right for the formal charge for the second O is 0, while when I do the calculation is 1, so therefore this is not normal. For IB mark scheme, as this one is 0, so IB choose structure B is the state is more stable because all the formal charge are 0, but when I do the calculation, none of them are stable. Therefore, structure A is unstable as the formal charge is not 0, and it goes the same with structure B because not all the formal charge are 0 as well. So that based on my calculation. Okay, so if you find this video is helpful, don't forget to subscribe. I finish explaining the paper 1 time zone, paper 2 time zone 2 HL May 2023. And don't forget to subscribe because I will do other past papers as well. Bye for now.